Hi everyone, this is Ms. S. from Excelsior Charter School, and today we're going to be covering Geometry Lesson 8-4 on the sine and cosine ratios. This is all the important information we're going to be covering today, and this should all be in your notes. Just a quick reminder about the parts of right triangles. Remember that all right triangles have a right angle, and that the side across from the right angle is known as the hypotenuse. And the two sides that form the right angle are both known as legs. Also a quick recap on opposite versus adjacent. If I put a person over here by the house, they are adjacent to the house, right next to the house, but opposite the lake from the lighthouse. And if I put them over here by the lighthouse, the opposite would be true. It's now adjacent to the lighthouse and opposite from the house. Also a quick comment, remember that when you are using geometry, we want to use degrees. And if you're looking at a calculator and it says you're using radians, that's bad. And you want to click on this button here to make sure that you're using degrees. A quick recap of the tangent ratio, which we learned the other day. Tangent is always opposite over adjacent. So if you're coming from this angle here, it would be the opposite side over the adjacent side, and tangent never ever uses the hypotenuse. So now we move into some new information on the sine ratio. Sine and cosine will both use the hypotenuse. So remember, it's important to go across from the right angle. So here's the hypotenuse here. And the sine ratio uses opposite over hypotenuse. So the sine is always opposite over hypotenuse. And so from this angle here, they've gone opposite side and then hypotenuse. And you would use the blue and the red. When working on the cosine, you're still going to use the hypotenuse, but you're going to use the adjacent over the hypotenuse. So as you can see here, the cosine is the adjacent over the hypotenuse. So from this angle here, you would use the adjacent leg and the hypotenuse in order to use the cosine ratio. A mnemonic device to help you remember this is SOHCAHTOA, and I usually write it a little bit differently. That's the way I like to write it. And then you can actually turn it into your equations for sine, cosine, and tangent. But SOHCAHTOA is a very common mnemonic device. The sine equals the opposite over the hypotenuse, the cosine equals the adjacent over the hypotenuse, and the tangent equals the opposite over the adjacent. SOHCAHTOA. Before we move on to the inverses, let's briefly cover the concept of an identity. An identity is an equation that is true for all allowed values of the variables. For example, in a right triangle, the sine of an angle is always equal to the cosine of the other acute angle. We'll go over that a little bit later. Now on to the inverse of sine and the inverse of cosine. You're only going to use these when you're looking for the angle. If you're looking for the sides, you're just going to use the sine and the cosine like normal. You might need to use a second function on your calculator in order to do these inverses, so let me show you what I mean. This might be what your calculator looks like normally, and if you look across here, you'll see the highlighted sections are sine, cosine, and tangent. If you want to use the inverses, what you'll need is to hit this up button here, or sometimes it says, second, something like that, depends on the calculator. And notice how this is highlighted now, and the sine -1, cosine -1, and tangent -1 are highlighted as well. So if you need to use the inverses, that's how you do it. All right, let's work on some of your homework now. This question wants us to write the ratios for the sine of m and the cosine of m. So I've written down those functions here, and if we start here at angle m, and we want to go, the sine is the opposite, so 4 radical 2, over the hypotenuse, which is always across from the right angle. So the sine of angle m is actually 4 radical 2 over 9. To do the cosine of m, remember, it's always the adjacent over the hypotenuse. So in this case, the adjacent is 7 and the hypotenuse is 9. So the cosine of angle m is 7 over 9. These problems want us to solve for x. Notice both of them are lengths along the triangle, so we're going to use the regular functions. So on the top here, we're going from angle 56, and x is the hypotenuse. So 10 has to be a leg, and it happens to be the leg that's adjacent to 56. So we're going to use adjacent and hypotenuse, which is the cosine. So I set up my equation. The cosine of 56 equals the adjacent 10 over the hypotenuse x. And then I'll solve this for x. And when I plug this in with my calculator, 10 divided by the cosine of 56 is approximately 17.88. And all calculators are different, you guys. Sometimes you have to put the 56 in first, and sometimes and then hit cosine, and sometimes you have to hit cosine first and then hit 56. It varies by calculator. To do our second question here, I'm going to start with angle 21. I am definitely going to use the hypotenuse here, which is 12, and then x is all the way across, so it's the opposite. So we're going to use the sine of 21, opposite and hypotenuse. And when I solve this for x, what I get is approximately 4.3. This next question here is also asking us for x, but please note that this time x is the angle, which means we're going to have to use an inverse function. We are definitely using the hypotenuse here across from the right angle, and we are also going to use this leg here, which is adjacent to angle x. So since we're using adjacent and hypotenuse, we are talking about the cosine. And when I plug this into my calculator, I actually do 5 and then divided by 8, and then I hit the equal sign or enter sign, and then I hit the inverse of cosine, cosine -1, and it spits out my answer as approximately 51.3. Again, some calculators are different, and you have to start with the cosine of inverse cosine, cosine -1, but I believe most Apple products is this way. And that's how you do an inverse. Good luck, everybody. I hope you guys all do great.